Hey everybody, it's Lester Martin, Dev Advocate here at Datavolo, and this is our community broadcast number tres, uno dos tres. So we're just getting this thing started, but we got another awesome quality guest today, another member of the technical team here at Datavolo. It's David Handermann. I'll let him introduce himself in just a second, as well as this topic, but I'll go ahead and pitch it a little bit. It's Apache NiFi 2. A lot of work has happened to get to the version 2 and beyond, and David knows all about that, so we'll probably venture into bits of that, but we're going to focus real heavily on the work that has happened to adapt to Kubernetes, not to adapt it, to take advantage of Kubernetes and get a lot of good things that we've had in the past. So with that said, I will say, before I cut it over, I will say we also posted, and we'll put it in the description, we'll put it on the little secondary page of links, a pretty good, a real good, an incredible, not pretty good, an incredible blog post kind of detailing these things. So you have that as well, but I encourage you, even if you're hearing this now, to listen to the conversation. We're going to go to it with a little bit more color. So, hey, David, welcome to the show. And
Thanks, Lester.
Yeah.
Great to be here. Yeah, so David Handermann, one of the software engineers here at Datavolo, and glad to jump in and talk about Apache NiFi, native Kubernetes clustering, something we've focused heavily on at Datavolo, and also something, it's a popular topic in the community. I see questions all the time on the Apache Slack channels and on the mailing lists on, hey, I want to run NiFi, I want to cluster it, and I want to do that on Kubernetes, taking advantage of containerization, taking advantage of the orchestration capabilities, declarative configuration that Kubernetes provides. So this is something that I've worked on, and for I guess since last year really began focusing on it, and continued to advance some of those capabilities with NiFi, and particularly launching it with the first milestone release of Apache NiFi 2.
Well, tell me this though. People have obviously been running NiFi clusters with Kubernetes for a while. What was the lift prior to all this? This is work in the product itself. What was the lift for somebody just to say, hey, I just need to run it on Kubernetes? And what was that effort look like compared to what I remember from several years ago when work days and stuff?
Right. Yeah, there's been, if you look for NiFi and Kubernetes, there's a number of articles out there, a number of good articles on step by step, here's the YAML definitions, here's the commands to run. But part of that is that NiFi clustering has been based on Apache Zookeeper, which is a solid product for service coordination. Taking that zoo theme and running with it. But how do you manage multiple services? Who's the leader? How do I share state? And so previously to NiFi 2, that was the only option if you wanted to run the NiFi in a cluster, whether on-prem or on virtual machines or in Kubernetes. You also had to provision and configure a Zookeeper cluster, and if security, authentication, resources for that as well, that you had to balance and maintain, and then keep those connections coupled together with your NiFi configuration.
Makes a whole lot of sense. I did a little short, having a little fun with the blog, and I don't know if you caught it.
Yeah, that was fun.
Picked on Zookeeper a little bit for, hey, Zookeeper actually is pretty darn cool for what it's done. It's a cornerstone for a lot of technologies. A lot of technologies have moved off of it over time. They feel like probably because so many have used it. I think that's a lot of them. Especially people that are very chatty with NiFi, with Zookeeper. They're like, well, if I'm chatty, my friend's chatty, we're all chatty. Either I have my own or purpose-built something. So this is better than purpose-built. This is build something generic, leverage the genericity of something. I got some questions about leader election, but I'm gonna wait to get there.
Okay, sure. So you want me to provide some more background on what the
go for it. I'm just interrupting you, man. When I stop talking, you can get back to your flow.
Yeah, sounds good. Sounds good. Yeah, so recognizing that the complexities around NiFi clustering in Kubernetes in the container space required Zookeeper. That was a key question in the past of how can we make NiFi clustering on Kubernetes easier to maintain, easier to troubleshoot, easier to configure. So work with some other folks who kind of scoped out this idea and the concepts around it, pointing to native Kubernetes features such as Leases, which is something Kubernetes itself uses, and say, who's the leader, who's the one responsible for. And on the Kubernetes core side, the Kubernetes scheduler, that's one of the core capabilities that Kubernetes makes use of to use the Leases feature. And then the other half of NiFi clustering has to do with shared state. So when you have a processor that's running, saying, show me all the files in this bucket, we need to keep track of the last one it saw so that you don't get duplicates and constantly reprocess the same thing. So when you're in a cluster, you want to make sure if one node goes down, another one's able to pick up at the right spot. And that's where another native Kubernetes feature, config maps, comes in as a way to, it's commonly used, that's the name, config maps, for shared configuration, but it can also be a read-write resource that's, again, native, backed by etcd commonly, but it provides a nice abstraction for services that say, hey, I want to have shared state stored somewhere in the
and you know,
cluster.
I remember I get the shared state. Remind me what happened before using config maps. Was Zookeeper used for that? I mean, okay, cool. And there's Zeno there and just storing what we need.
Exactly. Yep.
So that could have been chatty. That could have been very chatty too, right?
Very much so. Very much so. So yeah, you have to make sure, you know, do you have enough, you know, it doesn't take up a lot of space, but there's storage requirements for that as well.
Absolutely. No, go ahead. I had that question. I guess my question, I'll go ahead and throw it out there.
Sure.
When I first saw, you know, got into Hadoop 10, 12 years ago or so, and, you know, got into Zookeeper and all these things, and I heard this cool leadership election stuff. It took me a few years later when I finally circled back and really looked under the covers and said, oh, leadership election, at least in that world, if I remember right, was more like, hey, the first person to get here to say, I'm the leader, and there's some, you know, some mutexing to make sure nobody else can accidentally say that. That was election. It was more like first come, first serve. It's like a homeowner association. You want to be the president? You volunteer?
Hey,
you're the president.
You're in. Right.
Is it roughly the same thing when we say leadership election with the services we get from leases and that kind of stuff? First one to run, get it, and we'll just guarantee that we can't let two people get it. Is that kind of conceptually going on, or do they have some fancy election process? I would love that.
Yeah. At the core level, it's still those same basic, first one to take the lease wins. But you know, that's where Kubernetes and mediating that process comes in. So, you know, Kubernetes leases have a couple key properties. So of course they have, you know, who's the leader now, the current holder of that lease. But then the other important aspects are the lease duration and the acquisition time and the renew time. So, you know, all the members saying, okay, I want to participate in elections, so I'm going to watch that lease to see if the expiration happens and the current holder hasn't renewed it. So then I'm going to put my hat in the ring and say, hey, I'm going to try to update that. I want to become the leader and then take over. So, you know, there's certainly more details there, but those key properties to see how long, you know, a cluster leader can hold that lease before someone else in the cluster recognizes, hey, there's a problem.
It's part of the name, right? It's just part of the name, right?
Exactly. Exactly.
Like in a dynamic IP lease or something. I got to come back, but, you know, or someone else can grab it. That's
right. Yep. It's a good way to. Good analogy.
And where do these live? Where does the config maps? Let me jump to that about the state. Where does that lives in just your Kubernetes application, or is it's a shared? How does that live? Who can see that data? What's the durability of that data too? Because we're like, what if a pod or a node or something fails and we spin back up? But how do we feel comfortable that Kubernetes is not? What's doing that?
No, exactly. You share something, you want to make sure it's going to be stable. So that's why config maps are a core first-class resource of a Kubernetes API. So it's an abstraction layer, meaning the consumer, in this case NiFi, doesn't really care, you know, cares at a fundamental level, but doesn't care the exact mechanics of where it's stored. So that's where services like etcd also, you know, it has its own clustering algorithms, it has its own storage. So there's storage replication there in the backing implementation. And then, of course, like many other benefits that Kubernetes brings is that API abstraction. So from a consumer and integrator point of view, all you have to do is say, I want to create a config map, I want to update a config map, I want to set entries, I want to change entries in that config map. And you just work with those API abstractions. And that's where there's clients in Java, Golang, Python, all the popular languages for interacting with the Kubernetes API, and thus that abstraction layer makes it really easy to build, you know, complex, scalable, distributed systems, run them on Kubernetes with just some simple and more straightforward API calls.
Yeah. But the deployer of a Kubernetes environment can then pick how durable you want that to be. Are there options for that? Is that what you're saying? I get the
Yeah,
APIs.
exactly.
Okay, so cool.
Right.
So
So
you're
you
the
certainly have
NiFi
options
developer
there.
adapting this, you write to the API, then you make a
Hmm.
choice. Okay, well, that needs to be rather durable. It can't just live in.
Right.
Okay.
So, you can run Kubernetes on a single computer, right? There's Minikube and other distributions
Get what you get on
kind
something like
running
that,
Kubernetes
right?
and Docker. So,
Yeah.
it's only going to be as durable as your single little pizza box there. Or, you run it on something like Amazon EKS,
Right.
and they provide those abstractions. You set the number of Kubernetes nodes, so okay, I've got 2, I've got 5,
Hmm.
and whatever scale you need for your actual supporting
Right.
Kubernetes nodes, and then you've got durability there. So there certainly are infrastructure concerns. It's just sort of delegation of responsibilities. Is there, okay, who's maintaining the health of the Kubernetes cluster at a core level? Who's maintaining the health of the NiFi cluster? Oftentimes those people may be the same, but
Right.
at least you have the opportunity to uh,
Absolutely.
abstract
Take
that.
your hat and just turn around, and then you're still the same person. But yes, it's two hats.
Exactly. Switch hats. Oh, I'm this one. Oh, let me
Oh, the
go. You need to
deployer.
go to that desk, right?
I'm done with my dev hat. Where's my ops hat? I got you.
Exactly.
We'll
Exactly.
get you a DevOps hat. There you go. You'll be happy. And I know I'm still in your thunder. You probably had this little story you want to go through, but again, I just looked at the blog post. I just read. I'm just thinking about this, and I'm realizing that, like, heart beating, for example,
Hmm.
heart beating prior to these changes, was heart beating either real to, nodes heart beating to each other, or was it kind of using Zookeeper to, like, maybe like how Kafka does it, kind of, hey, I just keep mentioning that and people listen to, I think they call it a Z group callback or something. So when
Hmm.
someone there's a durable Z node or something bizarre like that. I
Hmm.
think that's what Kafka used to do. What was NiFi
Right.
doing prior to look into Kubernetes heart beating? Same, something similar, or
Right. In that case, NiFi node heart beating actually stays the same. So
Mhm.
there's, like I said, there's the leader election side, there's the shared state side.
Yep.
There's also clustered node to node communication. And
Hmm.
that part, thankfully, with the abstractions that NiFi has built over time, that
Yeah.
part stays the same currently. So nodes are still able to communicate to one another. Things like configuration requests. So you're in your flow configuration, you want to add a processor.
Yeah.
That's where, again, back to the leader election, that cluster coordinator role is the one responsible for coordinating, managing the state
Right.
of the flow configuration. So
That
you
makes
connect
sense.
to one node, it says, oh, you want to add a processor. Let me send that to the coordinator. The coordinator sends it out to the individual node so that
Yeah.
everyone has the same copy of the
And that's
configuration.
probably
So
just
as
the
far as
path
that
of the role.
goes,
And that was the
yeah,
role of the
that's
cluster coordinator in general, not just to push in the flow, but he'll be the one, obviously, that says, hey, I can't push your flow because somebody's gone. Okay, that makes more sense. So
right.
it really has
Hmm.
fundamentally had to change there, which is good news, I guess. So we have
Right. Yeah. So that made it
real
easy in one
yeah.
way
Yeah.
to implement the Kubernetes-based support. Is okay. We already have robust cluster node communication one to the other. It's
Right.
just this leader election concern that there wasn't an abstraction for. There
Mhm.
was, we also supported Redis as a shared state provider. So instead of, if you didn't want to use Zookeeper for shared state, you could use Redis or even write your own as a framework level extension. But leader election was something that although there was a Java level interface, it
Yeah.
wasn't something you as an additional party could extend and build your own edition, or even at the framework level, say we want to have different choices.
Right.
So, not trying to rag on Zookeeper, it's still great and
Yeah. Yeah. Of
necessary
course.
for VM or hardware-based deployments and clustering
Yeah.
there. But
And
now we
this
can support both.
Yeah, this is probably still, again, the same in many ways before or after Kubernetes, but I get walk us through kind of high level sequence. What happens if the primary node fails
Hmm. Hmm.
and the cluster coordinator's alive? I guess I'm trying to say the lease is great. The lease means I'm still
Hmm.
alive. I'm still the primary node. Oh, my lease is up. I
Right.
release the lease. What happens
Hmm.
long before the node was the lease time has come? All the other nodes are happy. Is it just simply as the cluster coordinator notices, oh, the primary node's gone, and signals to everyone, hey, we don't have a primary node, go nuts, try to nominate yourself? Is that roughly what's happening, or is it
Uh,
much?
Similar. It's a little different in terms of each node is responsible. So, as say, I'm a voter, in your homeowners association. I'm going, okay, there's one person that's great while he serves, but oh, he's no longer able to serve. Well, I'm going to throw my hat in the ring. So everyone in that association is participating and could join in or could throw their hat in the ring for the election. So it's more of a looking at who currently has the lease. Again, both there's two different roles, the coordinator and the primary node. And so when a node says, oh, I'm participating in this election, if it sees that the currently elected leaseholder is no longer accessible, then it says, oh, well, let's have another election. And then the process begins. And that's where, at a lower level, again, it relates to flow configuration. If you say only run this processor on a primary node, which is a common pattern where you don't want to get duplicate data, you want to have sort of one entry point and then disperse it out to each member.
Yeah, you're right. We didn't explain that. We didn't explain the pertinent. We're making the assumption. We got some NiFi lovers here, and
got some details.
And I would say my NiFi lover request. How often does this come up? Why do we need a primary node? Why don't we? I know why we need a single instance of a node list. That's a perfect example. We have an API that's not parallelized. Great, I get it. You guys know this. Why dumb programmer Lester says, why can't I just simply say I need to be running on one and let everyone be a primary node? That way you can spread the love on the what was the reason? This is not the topic today, but I'm wondering what's that? Is it just that we got around to it, or is there fundamentally some architectural thing that says, nah, that would never work because you know that answer? Because that's my
no, that's a great question, and it's come up before. I was like, why can't I just pick...
If I think of it, it's like the last thing everyone's ever thought about it when I think about it.
No, it comes up from time to time. Why can't I just say I want to run this processor on this node only, or why can't I just run it on all nodes? And some components are built to do that. You can run them on all. It's really kind of a architectural flow design question of how does the flow respond to or handle duplication? So, for example, you could have every node, let's take an event-driven handling example. So you could have every node consuming from the same topic. They all get the same message, but then the question is, what do you do now? So they each have a copy. Do they all send it to some destination system? Does it somewhere in the flow say, okay, I've got 5 copies of this. I need to deduplicate and shrink it down to 1 before I send somewhere. So, that's one of the joys.
You know what? I didn't cut you off because that's what I do. Cut people off. I'm going to cut you down. I understand why we need the notion of run it once or run it everywhere. My question is, I got 1,000 flows, 500 flows. And every one of those flows starts with, hey, pull the file system and then get the file names. And then, of course, spread those out.
Distribute it, right.
And I have to run all those on one node. I guess my point was it'd be nice, and this has nothing to do with our call today, so thank you.
Hey, it's a good tangent.
You say thank you. But I want in that checkbox, I don't want to say run on the primary node. I want to say run on single node. I don't even want to pick it. What I want to do is spread the love in case there's 600 processors that need to run on the primary node, because now I got to be a little busy. Do you know if that's well, that's my hard question for the day.
Yeah, that is a hard question. Yeah, I don't think it's been put quite that way, but and that can be a problem too, to have the primary nodes too busy doing primary node things. That why can't we distribute it off? So that may be something to explore. A way to say, like, don't pick one, because then you'd run into, well, what happens if that node dies? You got a single point of failure.
No, it'd be worse. It'd be worse because now everyone's in essence, the primary node isn't a legitimate thing. There'd be like this primary node table of primary. This processor runs on 4. This processor. So I get it. It's open source for taking contributions. Lester, shut up. Code it up.
That's a good question. You have to start having, leases for, lease of the day. I want to do this job, that job, and have leader elections for all of those possibilities. But no, it's a reasonable question.
But the good news is what I'm hearing is you haven't heard because you've been in this platform for a long time, that you haven't heard that really being a theme where we say, hey, there's so many things pegged in the primary node that itself gets so busy that it is impacting overall flow. So that's good news. That's good to hear. Cool.
Yeah, and I'll just bring that back to say, one of the challenges and one of the reasons I think that running on Kubernetes is such a compelling use case is that, when you only have a set number of resources, whether hardware or virtual machines, there's a natural tendency to run as much of your data flows on one cluster as you possibly can. Then you start to get into contention, the noisy neighbor problem. Kubernetes really allows you to have multiple clusters exactly, so you can more different, spread out those use cases so you don't have those kinds of issues.
Yeah. No, you're spot on. That makes a whole lot of sense. Get away from the one cluster to solve all world problems.
Right.
Yeah, and allow, and then you're right. You could be a team, a department, or a flow. It can be whatever makes the most sense. Perfect.
Exactly.
Well, hey, other stuff. I feel kind of foolish taking us down that primary node. I'm going to write me some
That's all right.
code this weekend. I got nothing better to do this weekend. I'm going to change the primary node architecture on the fly. No, we're not going to do that this weekend. But are there other topics on this blog that you want to mention about and talk about here, or just the whole topic? Again, I got kind of focused on that.
Yeah, I'll summarize it up. The first half of that particular blog focuses on the core NiFi capabilities around leader election and state management. The second half is really, okay, now you want to run NiFi in Kubernetes. What else do you need to know? And so that's where there are a number of other considerations, things like where are you going to store your repositories for content, for metadata? How are you going to secure communication between each node? And then how are you going to secure communication from cluster nodes to the outside world or to your private network? So, authorized personnel can get in, make flow changes. And those kinds of considerations get into how do you manage certificates? How do you rotate them? All those kinds of questions. So that's something where, we've spent a lot of time thinking about building solutions for that at Datavolo. But the point of the blog was to walk through, okay, you want to run on Kubernetes? That's great. Here's the building blocks. And how are you thinking about the rest of those pieces that all go into making a functional, secure, scalable cluster?
Awesome. Last question from me, and of course you can talk about as much as you want to. What about the person that's just not ready to go to Kubernetes in NiFi 2? Is it one of those things that got to go all in or not? Because I know some things are big. There's some changes that are happening in NiFi 2, and that's why it's called 2. Not 1 dot, whatever is 2 dot.
Yeah.
But is Kubernetes one of those you gotta be in or not in, or is it much more of, hey, you're more than likely going to use this because it makes a whole lot of sense kind of a model?
Yeah, no, it's up to you in terms of what your deployment needs are. Maybe you just need one node and you can throw a lot of CPU, RAM, and storage at that, and that's all you need. So in some cases, you don't need the complexity around clustering. So you do get a lot of benefits in terms of that high availability, scaling more easily, but by no means is it there's only one way to do it, sort of thing, and that's the beauty of NiFi.
Even for the shop out there that's got a 5-node cluster they've been running for the last couple of years, and they want to stay. They're like, I got it. I got bare metal. I know what I'm doing. I don't want to talk Kubernetes. They're fine as well. They can keep running Zookeeper.
Yeah, they can upgrade. They can keep using Zookeeper. Zookeeper continues to be supported. So yeah, it's there. It's certainly continues to be a valid use case.
Right. Awesome. And I have a feeling I know what we're doing with Datavolo Cloud. Yeah, we're just all in. We're going all
in. If you want to go to the cloud, though, you want scalability. You want to, not be stuck on your one set of hardware. Yeah, that's where these kinds of questions, and that's where this journey's taken us so far.
Beautiful. Well, hey, man, like I said, I learned a lot today. I did remind myself of my, we all have that list of things we want to build. And this primary node thing, I know I keep harping on it.
Now you're going to go right to your code, right?
It's going to stay there. I'm going to go push that way down on my list now, because I heard it's really not a problem now, Lester, because if it is a problem, just make more clusters. Let's use Kubernetes.
There we go. There are solutions.
There's always an answer.
Make it work.
You might not always love it. There's always a great answer. And actually, it's an incredible answer. This is the right answer. It's even, go to the cloud, use elasticity. I mean, as a guy that I know you didn't come up to the Hadoop space, but I came up that space and we pitched this one cluster, solve all
to rule them all.
Storage and compute together. And you know what? In that world, storage and compute together still makes a whole lot of sense. But these are
Mhm.
benefits of exactly what we're talking about: elasticity, cost, from
Yeah, scale up and
one to
scale down.
real easy.
Mhm.
Yeah, those things greatly outweigh. And then of course, networking and things aren't what they were, 15, 20 years.
Thankfully, yeah,
Definitely.
technology advances, changes the
Well,
game.
hey man, I hope you come back again pretty darn soon with us again. And this
Yeah,
is
let's do it.
off to one of those Trace community broadcast. And I appreciate your time today.
Great talking to you. Thanks for the time. Let's talk again soon.
Thanks, Ann. Bye-bye.
See ya.